Construct an angle 45° at initial point of an ray, of a given ray, and justify your construction. So we are looking at a ray first. So let's call it as AB. So with A as the center, draw an arc. So let's call this as D. So with D as center, cut with the same radius. Remember, this has to be same. So if this is around 3 centimeter, from D cut an arc which is at 3 centimeter away, and another arc at 3 centimeter away, E and F. So why is that we are doing this? We are looking at making an angle of 90. So with this we'll make an angle of 90. From F and E, if you happen to cut two arcs which are equidistant, then this is your 90°. Now let us call this as point M. So here we are constructing 90 but we want 45. How is this? Why is that we are doing it? We are using the concept of bisecting the angle, which is between 0° and 90°. See, D is at 0°, right? AB being the ray, D is a point at 0°, while M is a point at 90°. If we bisect this, that is, if we take the average of 0° and 90°, so what is that we are looking at? 0 plus 90 by 2, which is 45°. So we're looking at 45°. So if I bisect M and D, the angle between basically MAD, if you bisect this, we'll get 45°. How do we bisect? From M and D, we have to take a length which is more than MD and cut two arcs, and this thing will give us 45°. So this is how you will construct. So let's look at this practically on a sheet of paper with compass and protractor and all of that. So we will begin with array. So it has a start. At that start we are drawing an arc. Any radius, doesn't matter. It need not be 3. Just for the sake of discussion, I spoke about 3 centimeter. So with the point of, say, with the point D, which is the intersection between the arc and the line segment or the ray, cut an arc with the same radius, and the next point E, with the point E, cut one more arc. Again, as a continuation, do this to draw 90°. This is the trick. See, point is we have to take a length from those 2 points to construct 90°, is it not? So I just go with the flow, and you can see from the second point to we're going to cut an arc. So now we need to drop a perpendicular. So that's your perpendicular line. So this is half the way. The last bit is to construct 45°. So bisecting M and D. So that is your D, which is at 0°. So this idea of bisecting angles, that's very important. So we will understand why later, because there's a lot of example that will come across and you will understand why. So we have the first arc. Again, the arc length should be more than half the distance between those 2 points. And the second arc, and then we have a ray which will bisect the angle 90 degree, and that happens to be 45 degree. Right, so that's 45 degree by bisecting 90 degree. So let's come back to the screen. So this is a very important concept, bisecting angle between 0 and 90. If you bisect between say 60 and 90, then you will get 60 plus 90 by 2. So that is 150, 75 degree. Okay, so this idea of where you start and where you end, right, that is important because that will help you guys do things which are weird, right? You'll understand it a bit later. So this is a must for you guys to write. So before that, let me finish off the steps and the construction. Justification, sorry. So now the steps. So first we will begin with taking A and B as your ray. AB is your ray with point A as the center. So and some radius, draw an arc of circle. So this is your arc 1 with intersects AB. So this is AB. This arc intersects at D. Taking D as a center with some radius, draw an arc intersecting arc 1 at E. Okay, that's E. And draw another arc with E as its center with same radius intersecting arc 1 at F. So that's F. With E and F as center, draw arc with radius more than half the length of EF. So here we need to draw with more than half. We need to draw this. So that's point E. So we have PAB to be 90 degree. So let M be the point of intersection of arc AP and arc 1. So that's M. With D and M as a center with radius more than half of DM, draw two arcs. Okay, so with more than half, draw two arcs and say this is point N. So NAD will give you guys 45 degree. So now let's look at the justification part. It's going to be a bit lengthy. First we need to justify about 90 degree, then about 45 degree. So it will take some time. So we'll begin with 90 degree. So to get that this angle is 90 degree, which angle MAD, we need to take few steps. Write few steps. So beginning with triangle AED. So triangle AED is an equilateral triangle. That's because AE, which is equal to ED, which is equal to AD, all of them are radius. So with this in mind, we can tell angle EAD is 60 degree. So next thing is triangle EAF is another equilateral triangle. So here too, the reason is AE is equal to FE is equal to AF. All of them are again radiuses. So we have angle FAE2 to be 60 degree. So why is that we are talking about these two angles? See, end of it we need this particular angle to be 90 degree, is it not? So if this is 60 and if we prove that this is 30 and we got this entire angle to be 90. So that's the basic idea. So now the last step is telling that triangle APF is congruent to triangle APE, right? Look at where APF is, APF. So that's your APF. Now the one is your APE. They're congruent because of SSS congruency. So this comes because of AP is common, then AF is equal to AE, and then FP is equal to PE, and this is because of radius, and this is because of construction. And next thing is, we can conclude from this that angle FAP is equal to angle PAE, right? So that is one thing because of CPCT. And next thing is, since angle FAE is equal to 60 degree, so which can be written as FAP plus angle PAE, which is equal to 60 degree. So from 1, what can we tell? That angle PAE is equal to FAP, so this 2 will turn out to be 2 times of PAE, which is equal to 60 degree, then divide by 2. Oh yeah, this is from equation 1. So divide by 2 and you have that to be 30. Angle PAE is equal to 30 degree. So this is 30 degree. And from A and B, so by adding A plus B, we have angle EAD plus angle PAE, which is equal to 90 degree, and thus we proved it to be 90. With lot of writing, we ended up with this answer. And now coming back to this diagram, so same diagram, just that it is too congested. It will be too congested, so I'm taking up one more. We came back to this and we have to talk about in AD. So to begin with, we will talk about triangle ANM being congruent to triangle AND because of SSS congruency. So that is, AN is common, then AD is equal to AM, because of radius, them being radius, and MN is equal to ND because of construction. We have constructed in that way. So we have angle MAN, which is equal to angle NAD by CPCT. So let's substitute this into equation 1. So which tells that angle PAD is equal to 90 degree. That's equation 1. Or I think we should call this as some equation first. I don't know, I think I've used 1, so we'll call this as first. So we have, from equation first, we have angle PAD, which is equal to 90 degree. So PAD is angle combination of angle PAN plus NAD, which is equal to 90 degree. But equation second tells that these two are of equal angle measurement. So from second, we can tell that angle 2 times of angle NAD will be equal to 90 degree, and divide by 2, and we have NAD, which is equal to 45 degree, and so this is 45 degree. Okay, and that's your writing, that's your justification. So this is very important, bisecting of angles, the idea. steps of construction, and your justification. Please enroll to our program at chalkpieceacademy.com, wherein we'll be teaching you a lot more tricks for faster simplification and calculation, DIY projects. We'll code with Python. We'll work with Arduino Uno. There are a lot more magic tricks and the physics behind it. They're printable materials which will help you recap and understand things better. We'll have live revision and doubt session 2 months before your term exams. It's very cost effective. There would be no ads or any kind of distractions, and we have a dedicated app to help you guys with this.